This is a definite integration problem. So to solve this, we can see here it is exponential function x to the power minus x. So in exponential function we generally use this kind of technique where we write it as e to the power ln of that function y. So I have written this as integral of 0 to 1 e to the power ln of x to the power minus x dx. Now I can just move this minus x to the in the front of the ln. This is a logarithm property that we can use. So I have written it like this, and then also I am using the power series of e to the power y. So power series of e to the power, you can check it is summation into infinity 0 to infinity y to the power n upon n factorial. So now by using this power series, I am substituting this as summation n 0 to infinity and this function. After that, you can just you can see that here this summation is depending on n, varying from n, and this is dx. So we can just interchange the summation to the outside of integration because n is not related to x in any manner. So I am taking the summation out of the integration, and also I am taking this x out of this bracket, like x to the power n out of the bracket, and keeping the minus ln x intact. And after that it will look like this by taking the summation outside the integral and taking the integral inside. Now I'll do some substitution. For ln I will write ln x as minus u. So u will u equals to minus ln x, and then from there we can get dx equals to minus e to the power u du. You can see the substitution here. I'm using this substitution. Ln x is equals to minus u. By putting it here, it will become u to the power n, and x to the power n will become e to the power minus nu, and n factorial will remain, and dx will be written as minus e to the power u du. Now to change the limits, because our substitution has changed, so at x is equals to 0, u is becoming infinity, and at x is equals to 1, u is equals to 0, minus ln 1 is equals to 0. So some the range of the integral will be, limits of the integral will be from infinity to 0. Now I will do another substitution where I will substitute v equals to n plus 1 times u. Now you can see the substitution here. I am using this substitution. From here I can write dv is equals to n plus 1 times du. This substitution is just to make simplify this equation, because I can see here is I have n factorial in the numerator. I can use it if I combine it with u to the power n, it will become v to the power n upon n to the, and you can see by practice you can calculate, you can just see this kind of simplifications to simplify the equation. So from here I am substituting v is equals to n plus 1 times u. From there u this can be written as u to the power n can be written as v to the power n upon n plus 1 to the power n. So this, and then n factorial is in the denominator, and then e to the power minus n will be written as u to the power minus v, and because there is also a minus u, so it will become e to the power minus of u into n plus 1, and u into n plus 1 will be written as v, so it becomes e to the power minus v. I am combining this and this, I am summing the exponent, and then dv is equals to n plus 1 times du. So du will be dv upon n plus 1, so n plus 1 times raised to the power n plus 1, and from this e to the power n, and from this du. Now you can see if you take the n outside this integral, because n is not related to dv, so I can just take this n, all the terms related to n outside this integral. So summation 1 upon this everything of the n part outside, and then the integral on the v part, dv part, the function of v. And if you observe this v to the power n e to the power minus v dv from 0 to infinity, it is nothing but represents the gamma function for n plus 1, and this is n factorial. And this is also a very interesting topic. You can where we can understand the factorial of n outside the natural numbers only in terms of continuous integration, but it is a topic from another video first. this is the gamma function for n plus 1. It is equals to n factorial. So I am substituting this as n factorial, and then n factorial cancels out, and it becomes summation n is equals to 0 to infinity 1 upon n plus 1 to the power n plus 1, and I am writing n plus 1 as n. So limits will also get increased by 1, so it will get 1 from infinity 1 to infinity 1 upon n to the power n, and it can be written as this. So you can see interesting part here is that we had originally a integration sum of exponential function, and the result we are getting is a discrete sum of these numbers till infinity.